I wanted to do a couple, some more examples of solving absolute value equations. I know our time was a little short this week together, so I just wanted to record some extra examples. There are some on your homework where there's a value that's outside the absolute value bars, but it's still on the same side of the equal sign. And so I want to talk about what to do in a situation like that. And you're supposed to isolate the absolute value part before you split. We talked about splitting into two options. So before you do that, we're going to isolate the absolute value part of it. And to do that, we're going to subtract 5 from both sides. That's going to give us the absolute value of 2x equals 2. Once you have the absolute value part isolated, then you can split like we did in class. That would be 2x equals 2, 2x equals negative 2, and we can solve. Divide by 2, x equals 1, divide by 2. So after that it's the same. But I just wanted to show you what to do when you've got another number kind of outside the absolute value bar. So here's your absolute value part. This 8 is on the outside. So we're going to move that 8 by subtracting it and end up with the absolute value of 3x equals 6. And then we will split. 3x equals 6 or 3x equals negative 6. So you'll get your two answers from there. Let me do a couple more that are a little bit more involved. And you're more than welcome to pause the video and try them yourself, and then you can play the video to see if you're correct. But let me take a couple off the extra practice worksheet. I printed this from the website. Let's do 6 times the absolute value of 1 minus 5x minus 9 equals 57. And I'm going to pull one more off that worksheet. 3 times 3 minus 5r minus 3 equals 18. So here's a couple more, and it sometimes helps to take a different color. You'll notice I'm always switching colors. And so if you take a different color and kind of highlight where that absolute value bar is, it's kind of hard to see on this. Let me think. It's hard to see the different colors on this video, but let me see if you can see the different colors. Anyway, you want to isolate these bars. So we're going to add 9 to both sides. We get 6 times 1 minus 5x equals 66. Now, our brain, when it sees these absolute value bars, your brain associates them with parentheses. And it's very tempting to want to distribute this 6 into there. But these are not parentheses. These are absolute value bars. And we don't mess with anything inside those absolute value bars. We leave it alone. So instead of distributing that 6, we're actually going to divide both sides by 6. And what that's going to do is cancel that 6. You still have the absolute value of 1 minus 5x equals, now it's just 11. Now that you have those absolute value bars isolated, now you will split into two different equations. So it's a little bit of work up front. And then just like before, 1 minus 5x equals 11. 1 minus 5x equals negative 11. And we just solve the equation from there. This is a little backwards. So we have this 1 over here. We're going to subtract that off. Negative 5x equals 10. Divide by negative 5. X equals positive 10 divided by negative 5 would be negative 2. Same thing over here. We're going to subtract off that 1. That's going to give us negative 5x equals negative 12. Divide by negative 5. Here we have a negative divided by a negative, so it will be a positive. 12 does not divide by 5, so it'll just be 12 over 5. So we still get two answers just like before. Again, if you want to pause the video and try this other example, and then just push play, and you can watch me work it out. I'm going to go through this one. So first you want to add 3 to both sides. It gives us 3 times the absolute value of 3 minus 5r equals 21. Find those absolute value bars. It's very tempting to distribute, but we don't do that. We divide by 3, divide by 3. Still absolute value of 3 minus 5r equals 7. And now we split. 3 minus 5r equals positive 7. 3 minus 5r equals negative 7. And we solve each one. Again, subtract off that 3. Negative 5r equals 4. Divide by negative 5. R equals negative 4/5. And subtract 3. Negative 5r equals negative 10. Divide by negative 5. R equals a negative divided by a negative will make a positive 2. So it's a little bit of work up front to isolate that absolute value bar, and then you solve just like we did in class. There's one more thing I want to discuss. It's just kind of a side note. It's not that big of a deal, but I do want to mention it. Absolute value is never negative. Never negative. So if I have the absolute value of something equaling a negative number, that is not possible. It's not possible when you've got those absolute value bars isolated. It is not possible for it to equal a negative value. So the absolute value, when you have the bars on it, will not equal a negative number. If you're working something out and you get down to the absolute value equals a negative number, you just stop and you put no solution. And on the computer it'll be a circle with a slash through it. That symbol stands for what they call empty set, which just means there's nothing. Empty set, no solution. So let me just show you a couple quick examples of that, just in case. I think there's 1 or 2 on the homework that you'll run into where the absolute value equals a negative and you just stop. So if I have the absolute value of 2x plus 25 equals 21, or if I have negative 3 times the absolute value of 2x plus 6 equals 15. At first, these two look okay. They equal a positive number. But when we start working it out and moving things around, when we subtract 25, we end up with the absolute value of 2x equals negative 4. And that's when we have a problem, because we've isolated the absolute value bars and it's equaling a negative number. So then we stop and we say no solution, which is a circle with a slash through it. Same idea over here. Right now this looks okay. We will subtract 6. We get negative 3 times 2x equals 9. It still looks okay. We have absolute value here equals a positive number. However, when we go to divide by negative 3, the absolute value of 2x, positive 9 divided by negative 3 makes a negative, and that's when we have a problem. So once again, we have the absolute value of something trying to equal a negative number. That's a problem. Then there's no solution or empty set. So I just wanted to show you a couple of those. You might run into those on the homework. And if you ever get down to the absolute value bars equaling a negative number, just stop. There's no solution. All right, and that should be able, you should be able to get through questions 31 through 40. 31 through 40 of the online homework with absolute value equations.